Hi guys, so I'm here to discuss today the final question on the AP Calculus BC exam, and it's our typical question with question 6. We're going to deal with a Taylor series as usual. They we can't end a BC exam without a C infinite series FRQ. So let's just dive in here and you do a test for the interval of convergence. So this would be, we're going to use the ratio test for absolute convergence, where we have limit as n approaches infinity of, just standard notation here, of a sub n plus 1, with this absolute convergence, so we need to do an absolute value, over a sub n, and this should be less than 1. And this would go to, we would go to next step in the proof, limit as n approaches infinity of, and this is where we're going to do our a of n plus 1 form, x minus 4 over to n plus 2 over, now we're going to group this, n plus 2 times 3 to the n plus 1 time all over our a sub n, x minus 4 to the n plus 1 n plus 1 to the n. Okay, and how this would simplify to limit as n approaches infinity. And we're going to simplify this a little bit to help us. X minus 4, x minus 4 to the n plus 1 over n plus 2 times 3, 3 to the n times n plus 1 times 3 to the n over x minus 4 to the n plus 1. And this should simplify a lot of stuff. So as you'll see here, a lot of things will cancel out. So the x minus 4 to n plus 1 cancels out, the 3 to the n cancels out, a lot of stuff. So we're left with an x minus 4 over n plus 2 times 3, and we're also left with a n plus 1 here. And oh, forget, we're going to carry on the less than 1 here. Now less than 1 here, and a less than 1 here. And we can simplify this into x minus 4 over 3. Don't put this in parentheses to make it clearer. Times limit as n approaches infinity of these two n terms less than 1. And we know this limit will go to 1. So all we're saying is x minus 4 over 3 is less than 1. And this would be negative 1 is less than x minus 4 over 3 is less than 1, or negative 3 is less than x minus 4 less than 3, and this would be 1 less than x less than 7. But now we have to check the endpoints using convergence tests. When x equals 1, the series is a sum from 1 to infinity of x minus 1 minus 4 to the n plus 1 over n plus 1 times 3 to the n, or negative the n term of this series is negative 1 to the n plus 1 so it's an alternating series, n3 to the n plus 1 over n plus 1 times 3 to the n equals -1 to the n plus 1 times 3 over n plus 1. So we can say that the absolute term 3 over n plus 1, and we're going to use the alternating series test on this, so we say 3 over n plus 2 is less than or equal to 3 over n plus 1 for all n greater than or equal to 1, and limit as n approaches infinity of 3 over n plus 1 equals 0. So we can say that this series converges by the alternating series test. So when x equals 7, and then we can basically copy paste the statement here, except there's no alternating series. And here we can say the nth term of this series is basically the same, except there's no alternating term. And get rid of this and this. So apply a limit comparison test to show divergence of this series. So we show that the sum from 1 to the infinity of 3 of the n plus 1 is greater than 0, and the sum from 1 to the infinity of 3 over n is also greater than 0. So here we can use a limit comparison test. On the rules of the series. So we said n terms. And we can say let a sub n equal 3 over n plus 1 and b sub n equals 3 over n. So limit as n approaches infinity. So we want this to be a finite number of a sub n, b sub n equals limit as n approaches infinity of 3 over n plus 1 over 3 over n, and this will equal limit as n approaches infinity of n over n plus 1 equals 1. It is a greater than 0 term, so limit comparison test is valid. Since 3 over n diverges by the p series test, since it is a p series with p equals 1 is less than or equal to 1, by the limit comparison test, the sum from 1 to infinity of 3 over n plus 1 also diverges. And we're going to say the sum from 1 to infinity here. So, conclusion, after all that, we can say interval of convergence -1, and it include this and exclude 7. And there's our part A answer. And we did all that work just for one part of the FRQ. So let's move on now. We're going to find the first 3 non-zero terms. So basically we're getting the Taylor series of f prime. So we are just going to differentiate these terms. So let's route the Taylor series for f equals x minus 4. And we're just going to copy this from the problem. And this will simplify very nicely. And we just differentiate each term here. I think you can see where this is going. And this would be and we do a little simplifying. And let's include the general term. So this would be x minus 4 to the n over 3 to the n. And there's our answer for part B. There's a much shorter part than A. In part C, we're asked to verify the sum given a geometric series. Remember, the sum of a geometric series equals a sub 1 over 1 minus r. So we can identify a sub 1 equals x minus 4 over 3. And this value will be equal to our r. Sum equals x minus 4. This is a sub 1 over 1 minus x minus 4 over 3. Equals x minus 4 over 3 over 3 minus x plus 4. 3, so 3's cancel out here. Equals x minus 4 over 3 plus 4 minus x equals x plus 4 over 7 minus x. And we verified the part C. In part D, we have to determine convergence of f prime under one case. So this is a pretty easy one. We should have learned this in your class, but the Taylor series of a derivative will have the same radius of convergence, but not necessarily the interval, as the original function. So we found this convergence here in part A, where the radius would be 3. So we can say that x equals 8 is 4 units away from the center of the Taylor series of f prime, which is further away than the radius of convergence prime, which equals the radius of convergence of f equals 3. Since f prime x equals 8 is outside of the interval of convergence of f prime, the Taylor series described in part B does not converge to x minus 4 over 7 minus x at x equals 8. This can also be verified using the geometric series test. Since our r equals x minus 4 over 3, so at x equals 8, r equals 8 minus 4 over 3 equals 4 over 3 greater than 1. So the series diverges by the geometric series test. And this is our part D answer. You could do either of these, and I think either of them will get credit. And that's the end of the BC test. So it's a pretty long problem here. Long interval convergence with the ratio test and the endpoints. Make sure you do check your endpoints with convergence tests. Taylor series for f prime. Differentiate each term. Determine the rules just have geometric series here. Remember to use the sum of the geometric series formula. You probably learned this in pre-calc, but it's still important here. And remember the concept of radius and the interval convergence for easy point at the end. So thanks for listening here, and this was a pretty tough BC exam. Let's look through this. We had differentiation between the average value and average rate of change. That was and MVT prominence guys here. We also had a limit that looked easy. It's easier than it looked, and also fundamental theorem calculus. In FRQ 2, we had a polar curve, and we had to use the polar area formula and some related rates, but you could also just do a relationship between the different derivatives. Interesting you can line dissociation there because that does make the problem easier. We had the normal table question with IVT and trapezoidal approximations, a graph question with the candidate test and absolute extrema. We had a differential equation where we had to do implicit differentiation and do a Taylor polynomial with a Von bound, and then another Taylor polynomial we had the dedicated series question where we were doing the ratio test to determine the integral convergence and do some geometric series stuff. So I'd say definitely brush up on BC topics. This exam was kind of a weed out exam to see who studied the BC content. So thanks for watching, and I hope you support my future walkthroughs on other AP exams as well as future years.